Hi guys, so today we're going to be talking about areas of the plane figures that we've been studying, which is the parallelogram and triangle. We've actually been using the area of a triangle formula sporadically here and there, but now it's time to actually talk about specifically how we find those areas and understanding the formula. So what I've done here was I've taken just a couple cutouts of the formula sheet that we use, which is the Keystone formula sheet, okay? And we know that the base, I call it the base formula. The base formula that we know is that area of a rectangle. Area of a rectangle is length times width, but we also write that as base times height, okay? Where the length is what we consider the base, the height is our width. Now, look at the formulas for the other two plane figures. The parallelogram is base times height, same as the rectangle, and the area formula for a triangle is 1/2 base times height. You can see that repeated value of base times height. You'll also notice that in the formula, in the picture, it labels the sides. A and B are the two sides, and H is the height. Now, when we talk about H, or the height, we're talking about the altitude height. Okay? And you'll notice that's the same over here in the triangle. The H is the altitude height, the perpendicular height. Now, let's see where these formulas actually come from. So here we have a parallelogram, and we know that the opposite sides of the parallelogram are congruent. So these two sides here are congruent. We also know that the altitude is perpendicular to the base. So our height is our altitude, and we have the base for which is perpendicular. Now, we know from our formula sheet that the area of a parallelogram is base times height. Now, why is it? Why isn't it the base times, let's say, the side, which they call A? Well, watch what happens. If I take this right triangle, which is now created, and I know that these two sides here are congruent, I'm going to just translate this right triangle over here to the other side. Just like so. We know that that side is congruent, right? Because we saw that already, opposite sides being congruent. There's our height, and our base just shifts over. Because the base was before, if I just added them together, that's the same base, right? Those two parts added together, same over here. Now you can see how the rectangle is also a parallelogram. And in this case, the parallelogram is also the rectangle, the way that I've translated. And we will learn that every rectangle is also a parallelogram, therefore they're going to share the same area formula, which is base times height. Now let's look at a triangle. We know that the area formula of a triangle is base times height over 2, which that's actually just half of a rectangle. So what I've done was here, I have this triangle, okay, and here's my base that's marked, and my height would be this altitude. And if really the area is base times height over 2, that means I could double this triangle and create a rectangle from it. And that's what I have kind of outlined around my triangle. Now watch how we can do that. So with my altitude, my large triangle has been broken up into two right triangles. So what I'm going to do is I'm just going to duplicate these right triangles. So here I'm going to duplicate this right triangle. Ooh, now look what I just did. Hold on. Okay. And then I'm going to just rotate it. Fits right inside. So I'm going to duplicate this triangle, rotate it, and it fits right inside. And we just created a rectangle whose area is base times height. But yet when we remove those duplications, or the doubling of each of these pieces, we have half of the rectangle, which is then 1/2 base times height. Pretty cool.